So hello everyone and welcome to our interview. This interview is organized by the CBIM network to discuss semantic enrichment for building information modeling. My name is Flavia and I'm here with my colleague Connor. We are both PhD researchers in the CBIM network. CBIM is a Horizon 2020 funded project focused on training and research network in the area of cloud-based building information modeling. The network brings together leading universities, software companies, and research institutes from all over the world. And one of the universities involved in the network is the University College Dublin, UCD. And our guest today, Cahor, is from UCD. With him, we hope to demystify the concept of semantic enrichment, understanding current approaches, and also the greatest challenge hindering the semantic enrichment process of BIM. So without further ado, let's get started.
Yeah, hey, so good afternoon, Cathal. Thanks a million for taking part in today's interview. So let's start with a little bit of your own background and your current work and how it is that you kind of support the BIM methodology.
I suppose my own background is I'm a computer scientist by trade, so I'm continuously surrounded by software code and things like this. My own area of interest has always been around mining information from whatever sources it can be found. And generally, kind of over the years, what I've discovered with that is that you don't mine just one source of information, rather you try to access several different sources of information and bring that together. So in the context of, say, a range of different projects that I'm working on at the moment, one is to do with additive manufacturing. So we're looking at different things like process data, CAD files, different information there, and looking for patterns in the data. Similarly, for the work that I've been doing in UCD in relation to energy modeling and the like, that's focused on both neighborhood energy modeling and energy modeling at a national scale, where we're looking at the consequences of, say, the adoption of green technologies, or say, for instance, electric vehicles or the like, and the effect that that has on the transmission and the distribution networks. In both cases, even though they're both very diverse fields, the key is to find a way of combining the information and then being able to mine that information and enrich the different data sources through the combination enrich each individual data source through the combination of numerous data sources together.
Perfect. So could you explain, you mentioned enrichment, that's what this interview is about. So could you explain in as plain language as possible the concept of semantic enrichment as you understand it, possibly with respect to the BIM methodology?
Yeah, so there are several examples where we've carried out enrichment through understanding various data sources. So on one particular project, the New Trend project, we might have had neighborhood information that was captured, say, in a city GML format. We would have had systems, industry standard systems, that would have allowed us to query that information. Similarly, we had BIM management software, and we would have had representations then of several different buildings through those BIM representations. Oftentimes, what we would find is that information that was absent in the BIM representation might be present in the city GML or in other information sources. So what we created then was a semantic network of these different information sources, where we were able to create associations between the different representations, and then either dynamically by querying and merging the information together to present a result to the user, we would either query several different information sources, or else we would maybe carry out an enrichment process where we would query, for example, the city GML information, and then after discovering facts there, insert that information into the BIM representation for the individual buildings.
Okay, so to summarize, how we could understand semantic enrichment would be to take different data sources and give greater context by merging these data sources.
Exactly. So the data sources themselves have implicit context, and by combining them, we're able to take advantage of that context in order to, I suppose, enrich the sum of the parts by combining the parts.
And so our understanding of semantic enrichment is very much that it's on a spectrum. So on one end of the spectrum, you've got manual semantic enrichment, when somebody's, say, building a BIM model and putting energy, let's say, U values into the wall. And then on the other end of the spectrum, you've got, developments in AI and machine learning. Somewhere in the middle is maybe something to do with semi-automation, rule-based enrichment.
Yep.
Can you discuss that spectrum a little bit and give us some examples at each stage, perhaps?
Yeah, I mean, the information sources that we would have worked with would have been captured by numerous different stakeholders in those various projects. So again, in the case of Nutrend, you would have had architects, acoustic engineers, structural engineers, urban planners, and so forth. Each of those has their own particular view of the environment that they're operating in. And I suppose if you're dealing with something that's at a relatively small scale, then just bringing those people together in a room to have a discussion, that's a good way to exchange information and to, I suppose, gain a perspective on, extra perspective on the information outside of your own particular silo. However, as the scale of a project grows, that sort of approach becomes much more complex and time consuming. I suppose to the degree that it starts interfering interfering with someone's ability to do their day-to-day job because they spend their time exchanging information. So that's where we try to automate the processes of combining these different information sources. Now, we take both to create that semantic network, we use a rules-based approach where we define sets of associations or rules between the different information sources that allow us to create join points between those information sources that we can query across. And similarly, then once you're at the point of enriching, say, information for a particular set of buildings, perhaps, again, their BIM representation, again, you can take a rules-based approach at that point in order to define the information that you're seeking from the various sources. And I suppose to work towards automating that. Now, there's a couple of different ways that you can take to tackle that problem. You can take a purely programmatic approach where you're writing code, maybe Python or whatever it might be, in order to query those information sources. And then you're manipulating that information and inserting that information into a new representation. But over the course of time, what you find is that approach, which I guess for a computer scientist is probably kind of manual as well. It's not necessarily hands-on working with the representation, but you're writing code that's maybe a custom solution to a particular set of circumstances. A rules-based approach is more flexible because what it allows you to do is more or less can maintain the silos of information as they exist. But by having these defined relationships between those silos, then you're able to formulate dynamic queries across the silos. Now, the advantage of that is if one set of information is updated, then that update is represented in the network of information, as opposed to if you're querying that set of information, you somehow process it, and then you're using that information to update say a BIM model or something like that. Now, if a new version comes along, then you have to repeat that process and be aware of I suppose, the temporal aspect, the idea that there can be different versions of information and so forth. So the closer that you move towards something that's rules-based, or even better, where there's even deeper intelligence involved, then the more flexible you can be with your approach. It's easier to add new sources of information. It's easier to maintain the connections between those sources of information. The manual approach, be that generating code or be that like physically discovering information and manually moving it between representations, it will work to a degree, but it just won't scale either across over a period of time or across as you add new sources of information to your project.
Brilliant. That's really clear. I think we're seeing that in a lot of our work, that the burden of how much data is being processed is starting to make a bottleneck in admin, and that's really driving organizations to look towards automation of some sort.
And one thing that we would have discovered with, or I suppose noticed over the years as well, is as technology and as say sensors and other smart technologies are added to buildings, there's new sources of information becoming available as well. And oftentimes these are producing very large amounts of information, and regularly producing that information. So it becomes a kind of a moving target then at that point, because the scale of the information is growing, the velocity of the information is growing, and really it demands an automated approach in order to integrate those sources.
Brilliant. That's really clear. So just to move on, I mean, we know that there's a disjoint between what happens in academia and then what's actually going on in industry. At this moment, where do you believe we are on that spectrum, both in the academic world and maybe what's going on in industry?
So I think it can be a little bit hard to tell is the answer. So I think across the board, oftentimes what you find with industry is there can sometimes be a solution that's there, but either for commercial reasons or IP or sensitivity about the information, either for commercial or for regulatory reasons, the willingness to either share the information or to share perhaps approaches taken to manipulating and discovering information. Sometimes it's maybe not as forthcoming as you would find maybe in academia. So I suspect there are probably solutions to problems that are discussed in academia, but again, that kind of silo effect, either for commercial reasons or whatever it might be, prevents those approaches, I suppose, being disseminated and shared. And I mean, that's reasonable. Companies are there to make a profit. So if they have a competitive advantage, it's reasonable to expect that they would try to maintain that. I think from the academia perspective, I think oftentimes what you find is many of the approaches work well in a lab, but then when you try to scale them to a real world situation, that's maybe where that becomes a little bit more disjointed. So it's not necessarily scaling in terms of computing ability, but it's oftentimes I suppose the things that go on around an approach. So for instance, if you've got a solution in a lab, you might be starting from a set of defined data. The data, has been cleaned, has been prepared, is ready to go, and is ready to demonstrate a particular approach. Sometimes those conditions don't hold once you get to what we'll call the real world. The data may not be in the condition that you need it to be. What's the extra burden of that data cleaning going to mean to that approach that worked very well in academia? Similarly, the tools, that come with some of these academic approaches, nice user interfaces, being capable of being integrated into an enterprise, the interfaces that are available for accessing and consuming the information downstream of the analysis. What state are those in? So I think there's a kind of a necessity, I guess, from on the side of academia to understand that it's not just the cool algorithm that you need to produce, but you need to give some thought about carrying this forward to being a technology that can be adopted by companies for some sort of productive use.
Sure, yeah. So what I'm getting is that the lab environment doesn't leave the university and apply to commercial business contexts all that well, maybe, because they're testing a hypothesis?
Yeah, I think it might be just even more that, exactly, testing a hypothesis, proving that the problem can be solved, but then thinking about what you need to do to take that solution and actually make it applicable in the real world.
And I guess that's the expensive front-end development to make it user-friendly. And
it is, but it's actually where collaboration between academia and industry often comes to the fore. So, you know, oftentimes you'll be in a meeting and you might demo something. And, you know, I think that's then where industry can step up and say, that's a really interesting approach. How would it work in the following use case? Because this is the type of situation that we're facing. So it's actually having realistic use cases as well as the actual outcome of the analysis. So are we testing this form of analysis in a way that represents the real world?
So perhaps I was going to ask about the limitations at the moment. That seems like a limitation, just perhaps a lack of collaboration between academia and industry, and maybe more of that can alleviate that limitation. Would there be any other limitations that you see to growing this practice?
Yeah, data sets.
Mm-hmm.
Can we have some data, please? So I think it's always the case that I think academia struggles to find real world data sets. And I think this is probably something, again, where collaboration can help. And I think, again, it kind of comes back to maybe some of the skills that need, or some of the skills and some of the practices that need to evolve around projects. So the idea of data anonymization, things like this, in order to come up with approaches that allow people to create data sets that, while maybe not necessarily an accurate description of the real world, are accurate enough to allow evaluation of an algorithmic approach. So for example, you know, in the case of data anonymization, that you could create surrogate data that is representative of, say, an area, a county, or a small area or something like this, but doesn't, you know, so that you're able to take the information, the real information, and then you're able to change it in such a way that it creates a realistic representation of the environment that it's being applied to, but again, manages to comply with GDPR and things like that. So that might mean, you know, that you're literally changing aspects of individual buildings, but then that those, you know, what you lose in making those changes might be compensated for by having some similar representation somewhere else in the data set.
Yeah, so it sounds like, yeah, we're always, it's always going to be sensitive how you share data, and you know, being able to get industry or the private sector to release data. You know, we've had problems with obviously data privacy and security issues, so that's understandable. I suppose, well, what we're planning to do is a follow-up interview and focusing more towards the future of this semantic enrichment, towards the AI machine learning approaches. Where do you see areas of interest in that kind of further along the spectrum, and would you have any good examples that you've come across recently?
Well, I mean, say there was, I suppose, some of the examples that we worked on ourselves in relation to the ESIP project. We're currently publishing a paper with regard to that. So it was work between ourselves and UCD, several different departments within UCD, and then the ESRI, which is an economics analysis agency that's part of the Irish public sector, and basically analyzing how we can take numerous different information sources, some from public information, some from commercial sources, and then derive a model that allows us simulate the impact of the adoption of various green technologies and I suppose the replacement of traditional, fossil fuel-based technologies with greener energy electric alternatives, we'll say. So EVs, forms of home heating, home renovation, and so forth.
Brilliant. Well, we'll be looking forward to read that when it's out and share with our community as well. So I'll pass over to Flavia to close out. This has been brilliant, Cathal. Thanks a million. Very insightful.
Yeah, you're welcome.
So thank you, Cathal, for your time. Thank you, Connor, for mediating and asking all those brilliant questions. It was great to hear your inputs, Cathal, and in trying to demystify the semantic enrichment in the ACE industry. And we hope that it's now clear to our viewers, our students, that semantic enrichment is very much in line with the spectrum. It can be perhaps this fancy word phrase that we are seeing in the academia, but it's essentially means that anytime we are adding information, adding context, merging data, we are performing semantic enrichment in a model. And the challenge, as you said, apart from data sets, can be the domain knowledge and how we are encoding that into rules that can be automated in the future to generate in the context. So again, thank you, Cathal, for that, and we've learned a lot from you. And everyone that is watching, thank you for watching the video. Our next interview, as Connor already mentioned, we will address the later part of that spectrum, and we'll be talking about AI in semantic enrichment. And we also hope that you continue learning with us, with all the projects that we are developing within the CBIM research projects, and by following our social medias and websites. Bye, everyone. Nice.
Great.